Hey! Welcome back to Innovative Creator. The current view is that the universe began with what's called the Big Bang. Immediately following that was a stage of inflation, which was an exponential expansion. Who thinks 93 billion light-years across is massive? Well, that's just the part of the universe we can see. That's right, there's more, potentially an infinite amount more, stretching beyond what we can currently observe. It's a mystery, but guess what? We've got the James Webb Space Telescope to help uncover these cosmic secrets, combined with the brainpower of thinkers like Roger Penrose. We're pushing the boundaries of what we know about our incredible universe. The observable universe is pretty massive. When we try to get a handle on its size, we usually talk about what's called the observable universe. So, what's that, you ask? Well, it's basically the part of the universe that we can see from here on Earth. Think of it like this: light travels super fast, right? Like the fastest thing we know of. But even with that speed, light takes time to get from one place to another. Now, the universe is around 13.8 billion years old. So when we look at something really far away, we're actually seeing the light that left that thing a long time ago. If something is so far away that its light would have taken more than 13.8 billion years to reach us, well, we just can't see it because the universe hasn't been around long enough for that light to get to us. So, our observable universe is like a big bubble around us, going out as far as light could have traveled since the universe started. Turns out, that's about 46 billion light-years in any direction from us. Why is it bigger than 13.8 billion light-years if the universe is only 13.8 billion years old? How can it be that big? Well, it's because the universe has been expanding since the beginning. So, things that emitted light 13.8 billion years ago are now further away. Okay, so that gives us a bubble or a sphere around us that's 93 billion light-years across. Huge, right? And that's just the part of the universe we can see. There could be way more universe out there that we just can't see yet because the light hasn't had time to get to us. Now, within our big old observable universe bubble, there's loads going on. There are at least 2 trillion galaxies, and each one of those is home to billions or even trillions of stars, plus planets and other objects. And it's not just about the things we can see, like stars and galaxies. There's a whole lot of stuff in the universe that we can't see directly, but we know it's there. Stuff like dark matter, which is this mysterious substance that we can't see or touch, but we know it's there because of the way galaxies move. And then there's dark energy, which is even weirder, and it's what's causing the universe to expand faster and faster. Then there's also this faint glow of radiation all throughout space called the cosmic microwave background. It's like the afterglow from the Big Bang. And there are also things called neutrinos whizzing around, tiny particles that barely interact with anything, but we know they're there. Since we can't pick up any signals from beyond our observable patch, we really don't know what's out there. One of the strangest things about our universe is that it's not standing still. It's like it's on a constant growth spurt, always stretching and expanding. This means everything in it, from galaxies to clusters of galaxies, is getting further and further apart. Some things that we can see now will eventually drift so far away that they'll disappear from our view. This expanding universe also messes with the signals we get from faraway sources. It stretches out the waves of light, making them longer. We call this redshift. The further away something is, the more its light is redshifted. The universe is like a grand cosmic show, and we've got front row seats. But here's the catch: we're watching everything on a delay. You look at a star 10 light-years away, and you're not seeing it as it is now. You're seeing the light that left it 10 years ago. So, you're seeing the star as it was back then. The further away an object is, the older the light we're seeing from it. So, we can see way back in time, almost to the beginning of the universe, just by looking further out. That means by checking out objects at different distances, we can basically map out the entire history and evolution of the universe, right from the get-go to today. To the sun and the moon. Now, the sun and the moon may look close, but they're actually pretty far from us. Starting with the sun, it's a whopping 150 million kilometers away from us, give or take. That's around 93 million miles. We